Here's another fun one. We already know how to find the derivatives of our inverse trig functions. Here we'll learn how to do the antiderivatives of them also. So what we're looking for is the antiderivative of the inverse tangent of x with respect to x. And we are going to use integration by parts as the base here. That's kind of the driving force. So we need to figure out what our u is going to be. And we've seen this before. Normally we say u is supposed to be something that can be differentiated and gets simpler. Well, in this case, it's not exactly going to get simpler, but we are going to pick a u to be something that is easy to differentiate, or at least we know how to differentiate. We do know the derivative of arctangent of x, so we can use that as our u. The du would be, or the differential of u would be the derivative of that, 1 over x squared plus 1 times dx. And if our u was arctangent of x, that means that dv must be the other factor of our original integrand, which is just plain old dx. And so v, the antiderivative of that, is plain old x. So we can use our integration by parts here, use the formula that the integral of u dv is equal to uv minus the integral of v du. And we look at that integral, and hopefully by now our reaction to seeing that integral is, oh, perfect! Yay! X squared plus 1 is in the denominator, but its derivative, pretty much, is right there in the numerator. U sub will work. That's what I want you to be recognizing quickly. U sub is perfect for this. So I'll write it out because we do need to fix up a coefficient, so I'll make sure we see where that's coming from. If u is x squared plus 1, then du is 2x dx. I've got the x dx, I just need the 2. And so what I'm going to do is, I'll just rewrite that. So what we're going to do to get that 2 in there is just put it there and balance it off with a 1/2 in front of the integral. And that's okay. So now we can do our u substitution. So this original antiderivative is equal to x times the arctangent of x minus 1/2 the integral of du, that's the 2x dx, over u, that's the x squared plus 1, and the integral of du over u, well, hopefully you're recognizing that one, that's just the ln of the absolute value of u. And so our last step, plus c, our last step is just to put that u back in. So x times the arctangent of x minus 1/2 times the ln of the absolute value of x squared plus 1 plus c. And that is the antiderivative of arctangent. Now, it's not necessary that you memorize this, because that's quite a lot to memorize. But this is something that you're expected to be able to sort of replicate and get this if you need it. You can use a similar process to find the antiderivative of all 5 other inverse trig functions. And let's just take a quick look at what this would look like. Remember, this check we can do to see if our answer is right. The way it works is we graph our answer as a function. So we said it was x times the arctangent of x minus 1/2 times the ln of the absolute value of x squared plus 1. And I really don't care what that looks like. It does look kind of cool, but I don't care that much. What I care about is that the derivative of that looks exactly like the original arctangent that we were talking about before. And so those two functions are the same function, which means the derivative of our answer is equal to the original integrand. That means we've successfully found the antiderivative.